And then I would like to invite Team GlasCo from Scotland on stage. Give them a round of applause, please.
Cheers. How do I change slides? Just back and forth?
Yeah. Good luck.
Thank you. Where's Theodore? Okay. So, hi there, my name's Nat, and this is Theodore, and we're from Team GlasCo. I'm going to be presenting, and he'll be answering the difficult questions. So just a little bit about translatability in terms of what it can do. So we've already know that NT-proBNP is very useful in acute heart failure, and it could be useful in chronic heart failure with chronic measurements as well. But with a bit of research, we've also discovered that it could actually potentially predict future cardiovascular disease in the healthy population, and it could be even more useful than LDL cholesterol. So this is a large market that we would look to explore. In terms of translatability research, so we gained ethical approval for questionnaires and directed them to healthcare professionals and the public at the Science Centre event on the right-hand side. So the healthcare feedback was very useful, so we got lots of feedback, and particularly cardiologists tend to give full explanations of why things were useful, why things weren't. So for example here, a cardiologist is saying that it would be very useful for GPs for detecting acute heart failure, but a biosensor wouldn't be so useful for paramedics to detect acute heart failure. In terms of public feedback, again, it was interesting that they would be willing to pay a decent price for a biosensor that predicted future cardiovascular risk, and they were also willing to pay a good price for a biosensor that actually helps them if they had heart failure. So in terms of translating a prototype, we have 4 phases, which I'll talk you through, but basically it starts from phase 0, which is the prototype just now, to phase 3, which involves multi-analyte detection. So phase 1, basically we had discussions with industry experts such as SawDX, and currently the device is made from lithium niobate, or that's the piezoelectric substance, and it's the most costly material of it, and it costs about £100 per device in our labs, including Dyson raw materials. Decreasing the dimensions of this would take it to around £20 per device, so this would be what we're doing initially. Other manufacturing processes such as injection molding techniques over 3D laser print would also be introduced for the cartridges. And an initial investment in terms of we would give it to healthcare professionals, and then once they've used the device, we would take it back, strip it and refunctionalize it, and then give it back to them, and a recycling process would save a lot of cost. And phase 1 would allow us to kind of get our name out there, our brand out there, while we develop the further phases. So phase 2, we go from using wafers of lithium niobate to using zinc oxides, which would bring the cost substantially down. And there's a thin plastic layer on top that helps guide the wave called PMMA, and that could be conjugated into sheets and produced kind of mass manufactured. And there's currently no one doing that just now. We've done a freedom to operate search. So therefore, initial device investment in terms of giving them out would be recouped by selling the devices for about £2 to £5 to healthcare professionals and the public. And from our public questionnaire, most were willing to pay £2 to £5 or more per test, based on 1 test a week. In terms of phase 3 of our translation, we would like to conjugate, instead of just the one antibody onto the detection layer, we would conjugate layers of separate antibodies. So for example, troponin, NT-proBNP, CRP, that are useful in heart failure. And we would be able to kind of take measurements, strip, and detect them all in the same device. And we also developed a quick user interface prototype. So lots of the public that was spoke to requested that there be a smartphone app associated with it. So this could enable, if they're patients, to keep a record of their weight, their fluid balance, and also work to NT-proBNP targets. So in conclusion, we've done quite a bit of research and engaged with the public and healthcare professionals through questionnaires. We've developed the phases 0 to 3. Phases 0 and 1 would be rolled out initially with a recycling process, and then 2 and 3 after analysis and tests would then be rolled out probably in about 5 years' time overall. We've developed the mock app, and we've got exciting ideas for phase 3 for the multi-analyte detection. So thanks a lot for your time. If there's any questions. Pound, sorry. Yeah.
And you also said that it would be cheaper by picking other materials.
Yep.
Are you using those materials now, or do you want to use them, and is it feasible?
Okay, so we would bring them. I'll repeat the question, sorry. So what the gentleman was asking is basically, are we using the materials we talked about using in the future just now, and is it feasible, and how we would bring the price down? So the initial way we would bring the price down is by reducing the dimensions. So as we're cutting it just now, we're cutting it quite large. But that could be reduced to bring the price down to about £20 per cartridge. I'm not sure how much that is in euros, but quite a lot just now probably. And in terms of the zinc oxide, the second material we'd like to use, there's not as much evidence. There's evidence of its efficacy, but it's not used as much as the lithium niobate. So we would be looking to develop that ourselves. I don't know if you've got anything to add.
Also, the lithium niobate has a higher yield right now, and that's why we used it. The other material is a glass substrate with zinc oxide thin film, and this is what makes it drives down the cost. However, right now it has a lower yield, and more research is needed to be done to produce good functioning devices, a higher number of good functioning devices per batch. Yes, please.
Temperature control of the device.
The gentleman asked if we need temperature control on our device. Yes, lithium niobate has a high temperature coefficient, so it is temperature change is affected. That's why we use 2 devices in our cartridges to compensate for the changes that happen on the substrate only from temperature.
Yes, I want to control.
Which the one is used as control, and you measure the difference at one. Any other questions? No. Thank you for your attention, and please vote for us.